Intro Algebra Lesson 2-8B. Continuing our work with our probabilities, just a recap from the other day that theoretical probability is what would happen if everything were fair. It's in theory, doesn't necessarily mean it'll come out that way, but that's going to be favorable over possible. Experimental probability means we're actually sitting down and flipping the coins or rolling the dice. So we still want favorable, what we want, but this time it's not over what's possible, it's over how many tries we actually did. If I flip the coin 100 times and I get 40 heads, then the probability of heads experimentally was 40 over 100. All right, so that's over tries. And then odds compares what we want to what we don't want. These two numbers should add together to equal possibilities, because that's all you could get. Winners plus losers equals all the possibilities. All right? So favorable to non-favorable, what you want and what you don't want. So here is a list of all the possibilities that you could get if you were to roll two dice. You could have a 1 and a 1, a 2 and a 1, 3 and a 1, 4 and a 1, 5 and a 1, 6 and a 1, so on. You get 1 and a 2, 2 and a 2, 3 and a 3, and so on. So these are all the possible combos that you could actually get. If you count them up, there are 6 here and there are 6 there, which means there's a grand total of 36 possibilities. Someone might say, yeah, but Corey, here you've got like this 3 and the 1, and that's 1 and 3. Yeah, you're right, I do. But you'll also notice that they're different colored die to make sure that we know that a 3 on the red and a 1 on the white is not the same outcome as a 1 on the red and a 3 on the white. So just make sure you're aware of that. That's different. So according to this situation, we already know we have 36 possibilities. What's the probability of rolling a 7? A total of a 7. Well, total of a 7, if I look at it, 6 and 1 makes 7. 2 and 5, 3 and 4, 4 and 3, 5 and 2, 6 and 1. Those all make 7. None of the others will make 7. That's 1, 2, 3, 4, 5, 6 situations that are favorable. 6 that I want to have happen out of 36. So I would say 6 out of the 36 possibilities. Now, fortunately for us, that actually simplifies down, because both of these are divisible by 6, which would give us a 1 and 6 chance. So for every 6 rolls that I do, one of them should add up to make 7. Is that guaranteed to happen? No, that's in theory. It's theoretical probability. What's the probability of rolling a 9? Let me go back up here. Probability of rolling a 9. 6 and 3 make 9. 5 and 4. 4 and 5. 3 and 6. Nothing else makes 9. This makes 8. That makes 7. That makes 7. 8. That's all we have. Only 4. This time only 4 are favorable out of the same 36. So we would say 4 out of 36. But again, they're both divisible by something, in this case 4. 4 goes into itself once and into 36 9 times. Which means the chances of rolling a 9 are only 1 in every 9 tries. I had more chances of getting a 6 than I do a 4. I'm sorry, more chances of getting a 7 for a total than I do a 9. Because there were 6 chances where I could get a 7, and there were only 4 chances where I could get the 9. Alright, the probability of rolling a 7 or a 9. 7 or a 9, which means they're both going to satisfy. 7 or a 9? Alright, well that's 7, 7, 7, 7, 7, 7, and 9, 9, 9, 9. Those are all one or the other. I'd be happy with either one. So I had 4 here, and I had 6 there. That makes a grand total of 10. I had 10 that make me happy. So 10 out of the 36. Now they're both divisible by 2, which means that for every 18 rolls, 5 of them are going to come out to either 7 or 9. Alright? 5 out of 19 is a little better odds than 1 out of 9 and 1 out of 6. Because it happens more often. The likelihood is a little better. What's the probability of rolling a 12? On this problem, there is only one 12. That's it. there is only one 12 on the whole deal. And if there's only one 12, it's only going to be one favorable out of all 36 possible. And that is not going to simplify down. The chances of me rolling a 12 aren't very likely. What's the probability of rolling an even amount? An even amount. Well, all the even amounts, if you add 1 and 1, you get 2. But 1 and 2 make 3. So those are even, even. 2 and 6, even, 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 even. An even amount. Sure looks like 18 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. There are 18 favorable even numbers out of the 36. I'll clear my board. There are 18 out of the 36. But these are both divisible by 18. So we are actually dealing with 1/2. The probability is 50-50 that every time I roll it, I'm going to get an even number. Right? What are the odds of rolling a 9? Now this is different. Someone's going to say, didn't you already do that? No. I did the probability of rolling a 9. The probability of rolling a 9 was there was one favorable out of 9 possible. If there's only one favorable, how many losers are there? Well, there would be 8 losers. So the probability turns into odds would be 1/8. There's still the one favorable for every 8 losers. You might say, what? I don't understand. Well, look back again. There were 4 winners out of 36 possible. That means there's 32 losers for every 36 that are out there. All right? What's the odds of not rolling a 7? This is tricky. The odds of not rolling a 7. Now, you got to think about this. Favorable goes on top. On the bottom is non-favorable. Now, do I want to roll a 7? No. I want not to roll a 7. So the not 7 has to go on top. 7 then would not be favorable because I don't want to roll 7. So the 7s need to be on the bottom. So let's go back up here. Let's think about our 7s. There were 6 times that we rolled a 7. There were 36 possibilities, which means if there's 6 times that I could roll a 7, there's 30 times that I would not roll a 7. So you could say there's 30 times when I did not roll a 7, and there were 6 times where I did roll a 7. But they're both divisible by 6. I can use black. Which is 5 winners to 1 loser in that case. The odds of me not rolling a 7 are far better than they are of actually rolling a 7. Alright? So, some probability and some odds for this one situation of all those die.